Hello everyone, in this video we shall be looking at how to solve index equations. Believe me they are very interesting set of equations to solve. Now we have an example of an index equation on the board here, and we intend to solve this equation. So the first thing that we are going to do is to make sure that we write this equation in terms of a common base. So because of that, we have 4 raised to the power of x plus 1 minus 9 into 2 to the power of x equal to minus 2. And because of that, we are going to write this 4, which is not common to these 2, as a power of 2, so that the two bases will be the same. Now if you look at this equation, you might feel that it is not solvable since the bases are not the same, and just like Mr. John will say, it's a trap. So now let's see what we can do. So we can write this 4 as a power of 2. So we have 2 to the power of 2 all raised to the power of x plus 1, right? Minus 9 into 2 to the power of x equals minus 2. Okay, so now from our laws of indices, we know that we can simplify this 2 to the power of 2 to the power of x plus 1 by multiplying these two powers. So we have 2 to the power of 2 into x plus 1 minus 9 into 2 raised to the power x equals minus 2. Now because we now simplify this bracket here, the power, we simplify the power, we open up this bracket in the power, so that we have 2 to the power of 2 multiplied by x gives us 2x, plus 2 multiplied by 1 gives us 2, minus 9 into 2 to the power of x equals minus 2. So here we are going to split this power. We have a power carrying a sum, which means it can be splitted by using the multiplication law of indices. So 2 to the power of 2x plus 2 can be written as 2 to the power of 2x multiplied by 2 to the power of 2, then minus 9 into 2 to the power of x equals minus 2. Now 2 to the power of 2x multiplied by 2 to the power of 2 can be simplified to obtain this previous term. It's just a way of splitting it so that we can be able to add up or simplify the like terms and move on with the process of solving this equation. So let's continue. So simplifying 2 to the power of 2 gives us 4. So we have 2 to the power of 2x multiplied by 4 minus 9 into 2 to the power of x, and that is equal to minus 2. So we write this as 4 into 2 to the power of 2x minus 9 into 2 to the power of x will be equal to minus 2. Now here again we have a common power here, which is 2 to the power of x. If you look at this equation very well, it is a base and it's an index number that is reoccurring in this equation that we have on the board. So let's try to bring out that common index number. So if we are trying to do that, we modify this 2 to the power of 2x to become 4. So that is 4 into 2 to the power of x all squared. It's just a way of writing this 2 to the power of 2x in a way that will suit us, suit the process of solving this equation. So we write 2 to the power of 2x as 2 to the power of x all squared. There is no difference. From our laws of indices, we know that raising a power to another power is the same thing as multiplying the two powers. So similarly, we can split up the product into two different powers as we have it on the board. So minus 9 into 2 to the power of x, which is equal to minus 2. Good. So we have 4 into 2 to the power of x all squared minus 9 into 2 to the power of x equals minus 2. So we bring the constant term to the left hand side, so that we have 4 into 2 to the power of x all squared minus 9 into 2 to the power of x plus 2 equals 0, because the 2 was previously negative here and it crossed the equality sign to become positive. If you look at this equation, it is very much alike with the quadratic form of an equation. You have power 2, you have power 1, you have a constant term. So let's look at a variable that can be substituted to give this equation in form of a quadratic equation. So if you look at it, the 2 to the power of x is more or less like the variable in this quadratic equation. So we represent it with a variable. So we say let 2 to the power of x be equal to n. Since 2 to the power x is reoccurring, as if it is a variable and it is having a quadratic form. So we have 4. Now we are going to substitute wherever we see 2 to the power of x, we replace it with m. That's the substitution we are going to make, so that we have 4 into m squared minus, sorry, let me write this bolder, this m squared minus 9 into m plus 2 to be equal to 0. So you have, simplifying this gives us 4m squared minus 9m plus 2 to be equal to 0. You can now see that the full form of the quadratic equation is now reviewed. You have 4m squared minus 9m plus 2 equal to 0. Now the next question is, what method or are we going to use to solve this quadratic equation? It's up to you to use any of the methods. You have a lot of them. You have the formula method, you have the completing the square method, and the graphical method. But in this video we shall be using the factorization method to solve this quadratic equation. So by the factorization method, we are going to multiply the last term, the constant term, by the first term and see the product that we are going to have. So 2 multiplied by 4m squared gives us 8m squared, and we are going to look for 2 factors that can add up to give us the middle term and whose product will give us 8m squared. Let's think of those factors of 8m squared. Yeah, I think that is minus m and minus 8m. So we have minus m and minus 8m. Because if we look at this product, the product of 2 negative numbers always gives us a positive number, and then their sum, if we look at this, the sum of these two products, these two factors, is going to give us the middle term. So it is very much appropriate for us to replace the middle term with these two factors. So we go ahead to do that. So we have 4m squared. Now we are going to replace the middle term by the summation of these two factors that we've had. We have minus m minus 8m plus 2 equals 0. So we are still in the process of factorizing this quadratic equation. Let me wipe off this. Okay, so the next thing is we factorize by grouping. We factorize the first 2 terms and then factorize, followed by the factorization of the last 2 terms. So factorizing the first 2 terms, that's we are going to factorize these first 2 terms followed by the factorization of the last 2 terms. So what is the common factor between 4m squared and m is obviously m. So m is going to be brought out as a common factor. You divide 4m squared by m, you have 4m, minus you divide m by m, you have 1. In the second set of terms, the second pair of terms, you have minus 8m and plus 2. So the common factor there is minus 2. So you have minus 2 into minus 8m divided by minus 2 gives us 4m, plus 2 divided by minus 2 gives us minus 1, and that is equal to 0. So wherever you bring out a common factor, you must multiply each of the expressions you are factorizing. You must divide, each of the expressions you are factorizing by that common factor. So now we have 2 similar brackets which will enable us to finally factorize this quadratic equation. So we bring out one of the brackets as a common factor. We divide the first term by this common bracket. So 4m into m, 4m minus 1, divided by 4m minus 1, which we are taking out as a common factor. We divide to give us m as the answer. So that is going to be into m, then you have minus here. You divide the second term, 2 into m minus 1, by 2 into 4m minus 1 rather, by 4m minus 1. It gives us 2 as the answer, because 4m minus 1 cancels, divides out itself once. 1 multiplied by 2 gives us 2. So you have 2 equals 0. So now for a product, as we already know, for a product to be equal to 0, one of the numbers involved in the product must be 0. That is a condition that must not be swept under the carpet. So it means that 4m minus 1 is equal to 0, or m minus 2 is equal to 0. So for 4m minus 1 equal to 0, we are going to have our 4m to be equal to 0 plus 1, because this 1 was initially negative on the left hand side. Or for the second possibility, you have m to be equal to 0 plus 2. So we have 4m to be equal to 1, or m to be equal to 2. Now if 4m is equal to 1, to find the value of m, we divide both sides by the coefficient attached to m. So we divide both sides by 4. We have 4m divided by 4 will give us 1 divided by 4. Or in the second case, the value of m has already been established. So if we divide both sides by 4, 4 divides itself once, leaving us with m. So you have m to be equal to 1 over 4, or m to be equal to 2. So now we have been able to successfully solve our equation with the substituted variable, and we have the values of our substituted variable to be 1 over 4 and 2. But these are not the variables that we initially wanted to solve for in this equation. So we are going back to our original substitution so as to find the real solutions of this equation. So permit me to erase this part of the board. Good. So if m is equal to 1 over 4 and m is also equal to 2, it means that 2 to the power of x is also equal to 1 over 4, or 2 to the power of x is equal to 2. Since our substitution stated that 2 to the power of x is equal to the value of m. So making that substitution back, we are going to have 2 to the power of x to be equal to 1 all over 4, or 2 to the power of x to be equal to 2. Now we have also an index equation here. Now we must make sure that the bases are the same. We must make sure we express both the right and the left hand side as an index with a common base. So we know that 2 to the power of x in the first expression, or in the first equation, will be equal to 1 all over 4. Can be written as 2 raised to the power of 2, or in the second case, you have 2 to the power of x will be equal to 2 to the power of 1, because 2 without a power means that the power is 1. And then from our negative law of indices, we know that we can write the reciprocal of this power as a negative index. So we have 2 to the power of x will be equal to 2 to the power of minus 2. Because of the reciprocal of this power, we are going to take the negative index of the base. Or 2 to the power of x is equal to 2 to the power of 1. Now it is very much accurate and very much appropriate for us to compare the power, since the bases are already the same. So for the first case, we have x to be equal to minus 2, or for the second case, we have x to be equal to 1. Since the bases are the same, 2 to the power of x be equal to 2 to the power minus 2 means that x must be equal to minus 2, which has been established already. And the second case, 2 to the power of x being equal to 2 to the power of 1 means that x must be equal to 1. And this is the solution to our index equation. And virtually all index equations follow basically the same procedure of solving. Thank you very much for going through this video. I hope this video taught you a couple of things about solving index equations. Please don't forget to subscribe to this video and also like this video, because so that you'll be notified when I post upcoming videos. Thanks.